Okay, friends. So this is the module 2 of our business statistics course. And in this module, we are primarily discussing probability and distributions. So among that also, as in all the courses of this channel, in the theory part of probability, we will not give much focus. Our focus will be to define practical terms in probability and use those things in order to reach into the details of distribution. So our primary focus is distribution. To understand distribution, certain concepts and definitions need to be clarified in terms of probability theory. Only those parts we will be covering in this lecture, and the rest all probability theory we are not interested, because this is not a theoretical statistics or mathematics class. This is related to business statistics, and we are completely focused into the implementation part of it. Okay. So as I told you, some definitions of probability. So firstly, an experiment, which is any process of observation and recording. And this can be two types, deterministic and non-deterministic. So in case of a deterministic experiment, the outcome types are known. So that means what are going to be the outcome, what is going to be the outcome, that is not known, but the exhaustive types of outcomes that can result from an experiment, that is known. And then what is non-deterministic is the outcome types are unknown. That means you conduct the experiment, you don't even know what could be the possible outcomes. So one thing is this, that for an exact experiment, the outcome is unknown. For any experiment, the outcome is unknown, but the types of outcome or the possibilities, that also, if it is unknown, then it is a non-deterministic experiment. Next is event. Event is simply the outcome of any experiment. So example is very simple. Suppose you are tossing a coin, there can be two outcomes, heads or tails. Another example is you rolling a dice, and therefore there can be six outcomes. So every experiment will have one or more outcomes. Then sample space. What is a sample space? Sample space is set containing all possible types of events that can generate out of this experiment. So for example, if you take the toss experiment, then the sample space may be defined as h comma t, because these are the two outcomes that are possible. For rolling, the sample space is 1, 2, 3 up to 6. So this is the sample space. For slightly complex experiment, for example, tossing two coins. So if this is an experiment tossing two coins, then what could be the sample space? It could be like this: HH, HT, TT, TH, and TT. So this is one toss, this is second toss, this is first toss, this is second toss, this is first, this is second, this is first, this is second. So total 4 types of outcomes can be expected from that experiment. Then in the probability of an event, PA, according to the classical definition of probability, the number of favorable cases to an event A divided by the total number of cases possible to an experiment. So for example, if you want to calculate the probability of having heads in a tossing experiment, so then the number of heads that you have observed divided by the total number of event. So suppose you conducted 100 tossing experiments. Out of that, 40 for 40 you have found that heads had occurred. So therefore, probability of heads is zero point 0.4. So pretty much simple concepts. I know everyone knows these things, but I just need to mention these in order to define or explain certain things when we will study distributions. And of course, when we are discussing probability, probability cannot be greater than 1 or less than 0. It should always be within 0 and 1. That is according to the basic definition of probability. So now let us define certain other things. First one is the random variable. So if you talk about the random variable is not much different from event. In fact, it is the same thing written in mathematical terms. So when we will discuss distribution, we will see that everything is explained or described in terms of mathematical languages. So, but when defining events, we were using language only. So there were no mathematics involved. So this is random variable is basically a bridge, acting as a bridge, as if we are representing the events in terms of mathematical numbers, which can then be used in defining the distributions. So therefore, an event is equivalent to a random variable, and therefore if outcome is related to event, then random variables will have a value, and therefore these two are equivalent. So event is equivalent to random variable and outcome is equivalent to random value. So when events take an outcome, the random variable will take a particular value. So let us take this example. Again, the rolling experiment is conducted, and what is the outcome? Outcome is the odd number appears for roll of die. So what are the odd numbers? Odd numbers are 1, 3, and 5. So if you define a random variable, x is equal to the number that appears after rolling. So that can take values either 1, 3, or 5. So this is how we'll define random variables. So there are two types of random variables. One is discrete, another is continuous. But discrete random variables can take only discrete values. That means x1, x2, x3, x4 like this, and nothing in between. So there is nothing in between. Within x3 and x4, there is nothing. So either it takes x1 value or it takes x2, x3, and x4, so on. But nothing in between. So, but in case of continuous random variable, x will take any value on a given scale, and any real number can occur in that scale. For example, if x can take value between a and b, two limits, then within a and b, any real number can be the value of x, and therefore there is no discreteness. A entire continuous real number data is available for possible values of x. So now distribution. So before defining distribution in terms of statistics or mathematics, first focus on the English language. So if you talk about distribution, what do you understand by distribution? Distribution or distributing. If we only talk about English language, then what do we understand? Just think about it. You can pause this video also. Think about it. So In case of distribution, according to English language, I think it means distributing some things among some people, like maybe money or candy or whatever. You are distributing certain objects or certain things among certain people or certain subjects. That is the basic concept of distribution or distributing, if you will, in terms of English. Now use that same concept in case of probability. So in case of probability, what is distributed? So the probability itself, the probability or chance is actually distributed. So for example, if you have a discrete random variable x and x is taking these values x1, x2, x3, maybe x4 also. So the total probability, the total, these are the probabilities of so probability of x1, probability of x2, x3, and so on. The total probability has to be equal to 1. Think about this. So the random variable cannot take any value other than x1, x2, x3, and so on. So if you add the probabilities of these events, knowing that the probability will always be between 0 and 1, so and then if you add them, the at summation should always be equal to 1. And then, so what is distribution? Distribution means you are distributing this 1 in some way between these random variables values. So for example, zero point 0.2, zero point 0.5, zero point 0.3. This is one distribution. 0 0.1, 0 0.1, 0 0.8. This is another distribution. 0, 0, 1. This is another distribution. 0 0.5, 0 0.5, 0. This is another distribution. So in each case, suppose this is up to x3 only, there is no more values. So for each case, you see the total is always equal to 1, as if this total is getting distributed among these three members. So this is the only concept for distribution and nothing else is there. In case of discrete distribution also, and in case of continuous distribution also. You just have to remember this concept. So everything else will be clarified if you understand this. This is real simple, and I don't think it cannot be explained this simply. Anything simpler than this. So this is all about distribution. And if you talk about probability, there are two kinds of probabilities. One is the probability mass function. We are all talking about discrete distribution. Always remember. So probability mass function, also known as PMF, and cumulative distribution function, also known as CDF. PMF is simply the value of the PX. So the probability of x taking the value of xi. This is sometimes written in the short form as PXI. So those are written here. These are the PMFs. And if you add these PMFs, summation of PXI, it is always equal to 1. It has to be. And then what is the cumulative distribution function? It is Px less than equal to xi. So probability that the random variable will take any value less than or equal to a certain value. So for example, the first one is equal to the PMF itself, that is probability of x1. The second one is PMF of x1 plus PMF of x2. The third one is PMF of x1 plus PMF of x2 plus PMF of x3, and so on. So therefore, if this sum is equal to 1, then the row, the last row of this column has to be equal to 1 also. Okay. So this is the basic concept related to discrete distribution. So then when it comes to discrete distribution, we have two types of distribution to study here. The first one is binomial distribution and the second one is Poisson distribution. So in today's video, I am going to cover only the binomial distribution because I am trying to move very slowly, just making sure that you understand all the concepts with great clarity. These are the basic lessons of probability and distributions. If you understand everything with good clarity, then in the later stage of the course, it will be really helpful. So, in many books and texts, things are not explained in this lucid manner. So, that I am explaining here. So, if you follow these things, the concept of probability and all these distributions, like binomial, Poisson, and also the continuous distributions, the main concept and main fundamentals will be very clear to you. So let us move to binomial distribution. So for binomial distribution, first of all, you have to start with the storyline. So what does the binomial distribution say us? So for example, what is the storyline when we will use a binomial distribution? These are the fundamental things one should understand. So let us start from there. So first of all, there is an experiment which has exactly two possible outcomes. So for example, true, false, 0, 1, success, failure. You see, we exactly have two possible outcomes for that experiment. So this is the primary criterion. So you encounter any real life situation, you are totally confused which distribution to use. Always first ask yourself one question: do we have two exact outcome, or do we have multiple outcomes? If multiple outcomes, then binomial is not applicable here. If exactly two outcomes are there, then okay, there may be a chance that it is a binomial distribution, but then other things also has to be clarified. So therefore the second point, the probability of these two outcomes for a single experiment is known. So for example, tossing, we know the heads and tails are the outcomes, two outcomes. So the probability of one outcome, for example, probability of heads, is known. This will be known or given. So therefore the second one, even if it is not given, we can calculate by knowing that the total probability is always equal to 1. So therefore probability of t, if it is given, is equal to p, and the probability of false is equal to 1 minus p. So this is another condition. So what are the two conditions? First of all, two possible outcomes has to be there, and probability of each outcome for a single experiment must be known. Then what is the point number 3? Point number 3 is we are conducting this experiment n times. So please understand very well. There are two possible outcomes for what? For a single experiment. Probabilities of those outcomes are known for that single experiment. But now we are conducting that experiment n times. So this is very important. So this is the third criteria for binomial. First one is, I am repeating again and again just so that you can understand. The first point is one single experiment having two outcomes. Second point is two outcomes for that single experiment has particular probabilities which are known. The third point is we are conducting that single experiment n number of times. Okay. So primarily these are the three criteria for binomial distribution. Now, what is the fourth one? Fourth one is what do we want? So okay, this story is understood, but what do we want? So we are interested to know the probability of occurring T, that means true or false. I mean, either way, true or false for a certain number of times. So, what does that mean? So, that means you have conducted the experiment in number of times. We are interested to know the probability of occurring true or false, just one. Suppose true, number of times true, for example, k number of times. So, what is that probability? So, for example, probability of having k number of true outcomes within a n outcome, n experiment data. I am conducting n experiments. So, what is the probability of having k number of true? I think it is clear now. So, therefore, you see, I have written in red color. So, these are the two parameters of the binomial distribution. So, binomial distribution and a random variable x, if it follows a binomial distribution, then there will be two parameters. One is n and one another is p. So what is n? N is the total number of trials or total number of experiments that you are conducting, and p is the probability of success for a single experiment. I hope this is clear. So we just reiterate the table for binomial distribution that we already discussed in the discrete distribution. So there are number of times the event occurring, that is x1, x2, x3. This can be x4 also. This is truncated table. Then there will be PMFs. The PMF can be calculated using this particular formula, n combination xi. What is xi? Xi is this value. And then p to the power of xi into 1 minus p to the power of n minus xi. Or simply you will use this formula in Excel to calculate these values. So after some time, I will go to Excel and implement this formula for you. So I will do both. I will calculate using this fundamental formula and also using the Excel formula. And so what is cumulative distribution function? It is simply, you can use this Excel formula or just fundamental relationship. That means first use px1, then px1 plus px2, then px1 plus px2 plus px3, and so on. So what are the difference between these two formula in Excel? First one uses the 0 as the last argument, and the second one uses 1 as the last argument. This is the only difference. When you use 1 in the last argument, it gives you the cumulative distribution function value, and if you use 0 in the last argument, then it gives you the PMF, that means probability mass function value. Another thing that I want to mention here is each distribution, uh, both continuous and discrete, any type of distribution will be defined in terms of its expected value and variance. So in case of binomial distribution, the expected value is n into p and the variance is n into p into 1 minus p. And so what is the understanding related to expected value? It is the most likely value. Most likely value. So for example, if you toss n times, then what is the most likely value or most likely number of heads. Okay. If this is the question, then the answer is expected value. That means n into p. So that's all about binomial distribution. If you have understood this, you have known binomial distribution and you are ready to use it for any type of problem. I will discuss one simple type of problem and implement the entire calculation using Excel. And if you just watch these slides and the video content just 2 3 times repeatedly and observe the calculation procedure in the Excel sheet, you will be master in implementing any binomial distribution calculation. Okay, so let us move on to the spreadsheet and solve the problem using binomial distribution there. And after that, I will stop this video right here. In the next video, we will cover Poisson distribution because otherwise things will be too complicated for one video. So let us move to spreadsheet now. So here is the problem. A biased coin is tossed for 10 times. The probability of getting heads for a single toss is 0.4. So note that according to our definition, we are conducting this experiment for n times. So in this case, the tossing experiment we are conducting for how many times? It is clearly given 10 times. So is your n is equal to 10. And what is p? P is probability of getting head for a single toss, that is equal to 0.4. Okay, so now what could be the possible outcome of this random variable x? First off, you need to define the random variable x. So what could be the definition? Definition is x equal to number of heads appearing after tossing 10 times, right? So this is our definition of random variable x. So how many value can x take? Starting from 0, there can be 0 heads, 1, 2, a maximum up to 10. So you are conducting 10 experiments, that means 10 tosses. Out of that, maximum 10 times you can have heads and minimum 0 times. So based on this, calculate the PMF. I will use both algebraic formula as well as Excel PMF function. So the algebraic formula is this one. So let us write it down. Combination of number chosen is this one into p to the power of xi into 1 minus p to the power of n minus xi. And if you use the Excel formula, then binom dist numbers is xi, the number of trials is n, and probability. And then since this is PMF, the last argument is 0. So you see, both are returning the same value. So extend this. This is happening because I have forgotten to fix this. Okay. So these are your values. There's an Excel function. These are your values. They're perfectly matching, as you can see. Then what is the CDF using fundamental relationship? That is simply this one, then this plus this, then this plus this, this plus this. So always use the most recent PMF value plus the CDF updated up to the previous value. So that will give you the CDF of the recent value. And if you want to calculate this using Excel function, then binom list numbers, number of trials, probability, and this time last argument is 1 because this is CDF. So the total is always equal to 1, and the last row for the CDF column will always be equal to 1, as we can see here. So this is the complete table. I have just implemented these two relationships in this table. So now you may encounter certain questions here, types of question. For example, probability of greater than 5 heads, probability of less than 3 heads, probability of less than or equal to 2 heads, this type. So how will you calculate probability of greater than 5 heads? That means what? Probability x equal to 6 plus probability x equal to 7 plus this up to probability x equal to 10. So that is the greater than 5. So how can we calculate that? Simply this, you can add this, or you can calculate this like this: 1 minus probability less than equal to 4 heads, right? This and this are same. If you subtract probability of less than equal to 5 heads from 1, you will get probability of greater than 5 heads. So how to calculate that? 1 minus probability less than equal to 5 heads, it is the CDF value, this one. So see, these and these are equal. Similarly, probability less than 3 heads will be how much? Probability x equal to 1 plus probability x equal to 2, also probability x equal to 0. Anything else? No. So simply sum of these three. How else can this be calculated? So you can also write this as probability x less than or equal to 2. This and this are equal. And what is the value for this? This one. So see, again these two are matching. So this and this are equal. So in this way you will calculate different probabilities. And the last thing you should also know is the nature of plot for the binomial distribution. So for that you can select this data and go to insert scatter plot. Always use this particular option, dot plots. So do not use this option. This type of option you should not use. Why? Because binomial distribution is not a continuous distribution. So you cannot have line joining these dots. They should be in this form, separate discrete values, because remember this is a discrete distribution and there is nothing between 0 and 1, 1 and 2, 2 and 3, only 0, 1, 2, 3, 4, these values existing. So therefore the orange color line will represent, not line, the orange points will represent the CDF and the blue points will represent the PMF. Any kind of binomial distribution, if plotted, will give this type of result. The slope and flat nature or the actual shape of the distribution depends on the value of these two parameters n and p. So I think that is all about binomial distribution. If you have any doubt, any clarification is required, please use the comment section to ask me. Then I will cover that in the next video. Otherwise, in the next video, we will cover Poisson distribution and the elements of Poisson distribution, parameters, and its similarities and dissimilarities with binomial distribution. So with that, I am closing this video right now. Let us meet in the next video in the next episode. Thank you for watching this video.